This conference will now be recorded.
Good morning, everyone, and welcome to our annual organizational meeting and the board's January meeting. For members of the public attending remotely, we ask that you please close other programs on your computer or phone, silence your cell phone, and mute your audio when not speaking. Agendas for today's meeting are available at hrbrrd.ny.gov under board meetings. The conference organizer will monitor the program's chat function for anyone wishing to address the board during public comment period during the meeting of the full board. For anyone wishing to address the board, kindly use the chat function or email brao@hrbrrd.ny.gov or simply speak up during the public comment period during the full board meeting. For anyone tuning in today to watch the presentation on the upcoming Conklinville Dam project, we ask that you use the chat function or email any questions or comments to hrbrrd.ny.gov, and we'll responses to all questions on our website in our upcoming newsletter. Let us begin with the Pledge of Allegiance.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I now call the annual organizational meeting to order. I need a nomination first for chairperson.
Do a quick roll call, Mr. Chair.
Oh, it's on, okay, sorry.
Board Chair Mark Finkel,
Here,
Ms. Allen, Mr. Byrd,
here,
Mr. Candido,
Here.
Mr. DeWitt,
here,
Mr. Hayes,
here,
Mr. Reagan.
here,
Executive Director Callahan here, Mr. Fulton,
here,
Mr. Minicha,
here.
Ms. Rozicki.
Here.
And Rob Leslie is excused, Mr. Chair.
Thank you. I need a motion to adopt the meeting agenda.
I make that motion.
I'll second it.
All in favor?
Aye.
Aye.
We need now we can go to the election of officers. I need a motion for a nomination for chair.
I would like to nominate Chairperson Mark Finkel.
Do we have a second?
Second.
All in favor?
Aye.
Any opposed? Next, I ask for a nomination for the first vice chairperson.
I'd like to nominate Mr. Ken DeWitt.
We have a second?
I'll second it.
Any discussion? All in favor?
Aye.
Any opposed? Now I need a motion for second vice chairperson.
I would like to nominate Miss Nicole Allen.
We have a second?
I'll second.
All in favor?
Aye.
Aye.
Any opposed? Now I need the appointment of the secretary treasurer and assistant secretary treasurer.
We got for secretary, Mr. Leslie. For treasurer, Mr. Minicha. And for assistant secretary treasurer, Mr. Fulton.
We have a second?
I'll second.
All in favor?
Aye.
Aye.
Opposed. Now we have the designation of our official newspapers, and we're asking for nomination for the Times Union in Albany and for the Watertown area, the Watertown Daily Times, and this calls for a roll call vote. So could you call the roll, please?
Yes, sir, Mr. Chair. Board Chair Mark Finkel,
Aye.
Ms. Allen, Mr. Byrd,
Aye.
Mr. Candido, Mr. DeWitt,
Aye.
Mr. Hayes,
Aye.
Mr. Reagan.
Aye. The motion carries. We have our newspaper. Last is the tentative dates and locations of our 2026 board meetings, and it's on page 2 of the board packet. But I need the motion to adapt the schedule. You have a motion?
I'll make that motion.
Second,
I'll second.
all in favor?
Aye.
Aye.
Opposed? That being the business of the organizational meeting, I'll ask for we adjourn the.
So move.
Second,
Second.
all in favor?
Aye.
Aye.
Good job, Mark.
Congratulations.
Yeah.
Thank you.
We will go right into the regular board meeting agenda. So I will call the January board meeting to order. Roll call.
Board Chair Mark Finkel,
Here.
Ms. Allen,
Here.
Mr. Byrd, Mr. Candido,
Here.
Mr. DeWitt,
Here.
Mr. Hayes,
Here.
Mr. Reagan. Here. Executive Director Callahan here, Mr. Fulton.
Here.
Mr. Minicha.
Here.
Ms. Rozicki. Rob Leslie is excused, Mr. Chairman.
Yes. Motion to adapt the meeting agenda.
I'll make that motion.
I'll second.
Any discussion? All in favor?
Aye.
Aye.
We have no guests, I guess?
We'll be doing introductions on the folks that are here as part of the presentation in just a few minutes, Mr. Chair.
Yep.
Otherwise,
Public comment is, nobody signed up here. Is there anybody out there who wants to make a public comment to the board? Hearing nothing, we will move to the approval of the November 13th regular board meeting minutes. Motion to approve?
I will.
Second?
I'll second.
Any discussion or corrections? All in favor?
Aye.
Aye.
Next, the report of our executive director, Mr. Callahan.
Thank you, Mr. Chairman. Happy New Year to all, and happy State of the State Day to all as well. In recognition of the robust presentation that we'll receive today, that everyone is anxiously awaiting, I'll be brief. Just note a couple of things from my report. Permit season is upon us. You'll probably hear more from Ms. Rozicki about that, but really appreciate the efforts the whole team has put into place to further refine and improve our online permit system. I'm not going to steal any thunder from Stephanie to tell you how we're doing so far, but it really is great to see so many people responding positively to the customer service enhancements that we've put in place. And we thank the whole team for working so well together on that. I just also want to note, again, you'll see in my report that I attended the Tremie Pour up at Indian Lake towards the end of December. A real milestone relative to the emergent work we've had up there. Great to see that project, very complex, coming together, as well as attending with Mr. Fulton and Mr. Mosier, the kickoff meeting for the Old Forge and Six Lake projects. And obviously, you're going to hear about Concordville today. It's just remarkable to think, if we were sitting here 5 years ago, to be in a place where we're really addressing all of the regulating district's capital needs within this time period with the uphill challenges we were facing at that time. So we thank the board's support on that, and obviously we thank the state for coming through for us in a big way. And with that, Mr. Chair, I'll yield for any questions the board may have.
Any questions, comments? Thank you. Good report.
On the litigation, as I read that, I didn't quite understand what was in the packet on that from Rob of going forward. So does that mean we've actually moved forward, or is there still a period here where, and is there any negotiation taking place during this period?
I don't want to be too mysterious, Mr. Reagan, but we are at a point in this process with the Attorney General's representation of us that we'd probably be well advised, because we know a lot of people are obviously watching these meetings to go into executive session, which we could do a brief executive session if you like at the end of the meeting today. But certainly some things to report.
Is it moving forward?
Yes.
Good enough, John.
Thank you there.
Very good.
My only next question is, will I be alive when it's resolved? Okay.
Our next item is the presentation by the Office of General Services and Colliers Engineering on the Conklinville Dam Rehabilitation Project.
Thank you, Mr. Chairman. I'll introduce Mr. Fultan in a minute, who will in turn introduce our colleagues from OGS. And finally, we're going to get a presentation from Colliers Engineering and Design. I would just like to ask anybody that's participating remotely to mute just temporarily, because we are not speaking. Please mute your microphone. I'm just going to wait until we see that. I'm going to ask Megan and mute a couple microphones. Thank you. So, Mr. Chairman, this process has been a long time in the making, as you know, long before certainly I arrived. The chief engineer working with the consultant engineers to get this project to where we are today. Fortunately, as we know, we had a fairly unparalleled level of success with the state in obtaining external funding for the project, and they retained Colliers Engineering and Design to bring us to where we are today. So it's been a long time coming. It's a project with a lot of moving parts, very complex, but we're very excited to bring the board up to speed on where things stand. And with that, the person who's had the laboring oar to get us to this point over so many years, I'll yield to the chief engineer.
Thanks, John. As John mentioned, our current effort toward rehab and rehabilitation of Conklinville was initiated in 2007, producing some preliminary engineering assessments on certain features of the facility. In 2016, the district began a more thorough evaluation of the entire facility, including all structures and mechanical equipment. The engineering evaluations, which began in 2016, culminated in a draft conceptual design report in 2020. In 2021, as John mentioned, the Office of General Services, on behalf of the district, initiated development of final phase engineering evaluations for the rehabilitation of Conklinville Dam, an OGS effort led by geotechnical engineer and project manager Thomas Morgan, has brought us to a final design phase for Conklinville Dam rehabilitation, which Tom will now introduce.
Send it over to our colleagues at OGS.
Thanks, Rob. So my name is Tom Morgan. As Rob's already indicated, I'm the project manager and team leader for OGS on this project. My background is I joined OGS in 2020, and before that I spent 15 years in private consulting, primarily working on dams, which is how I kind of got saddled with this project. So, but it has been a very good and interesting project to work with. So I will introduce some of the other members here of the OGS team. So Brady.
Yep, I'm Brady Sherlock. Good morning. I'm the director of the Division of Design. So I work with Tom and the rest of my team helping manage all of the design projects in the OGS portfolio for our various client managers or client agencies, sorry. So just happy to be here this morning and give you some updates and background on this project.
And Kristen Sabaro here as well with the Office of General Services Design and Construction. I'm the Director of Environmental Programs. Tom is a team lead in my group, and we oversee the DEC portfolio, which is why this project falls in our realm of responsibility. My main role is to oversee the project and help be a liaison between our client and the project team and help navigate and mitigate budget and schedule risks as they come up.
All right. So Josh, will introduce yourself.
Sure. Good morning, everybody, and appreciate the opportunity to talk to you this morning. If I could just ask that OGS mute because I can hear myself. Sorry about that. again, thank you for the opportunity to speak with you this morning, both the board and the members of the public that were able to join the presentation. My name is Josh Rupp. I'm the project manager on behalf of Colliers Engineering and Design. Our consultant team, along with OGS in the district and also the DEC, who's not on this call, has all come together. We've got a number of different types of engineers. You heard the word geotechnical engineer, that's a soils engineer. We also have hydraulic engineers, mechanical engineers, electrical engineers. I happen to be a structural engineer. I've been with the firm about 22 years, and I will quickly introduce Rex before he passes it back to me, and I'll start walking you through some of the project details.
Yes, good morning. My name's Rex Powell. I'm a civil structural engineer. I'm the design lead on this project. My background is primarily dam safety, hydroelectric, and navigation structures for, a bit over 40 years now. But I do also get involved in geotechnical, hydraulics, and mechanical designs as need be. Josh?
Thank you, Rex. For our agenda today, we've already gone through the 5 minutes of introductions at the top of the screen here, but the meat and potatoes of it is basically a project overview where we're going to first familiarize you with the site. I realize maybe not everyone from the public or the board has had a chance to see this up close, so we'll share a number of slides to show you what it looks like in its existing state, and then also share some of the work that we've put into the project for remedial measures and explain the how and why as to how we've approached those remedial measures. I realize there's an interest also in schedule, so we'll go through what our schedule is for execution of the project. Construction requirements, I'll recap. That's just basically describing what some of the impacts of the project might be, whether that's noise, dust, water level, those sorts of things. And then lastly, I'll close out with our cost estimate, our opinion of probable construction costs, but most importantly, want to leave a good slot of time for folks to ask questions where we might have not covered something that provides an answer. So let's start off with just getting familiar with the site. This is a drone photo from above the roadway near Conklinville Dam in the background, and certainly a key feature to the site is the EJ West powerhouse. We are not doing anything as part of this project with that powerhouse, but it's certainly a notable feature at the site. Coming from the powerhouse toward us in the photo is what we'll be terming the spillway. This has a concrete cap where my cursor is, founded on a pretty large rock mass foundation. And of course, the spillway is fed by the spillway channel here, off to the left of the photo. In the foreground, and we'll be talking about this a lot, is the outlet structure. So there's a control house on top that's a pretty characteristic element of the site, and then a really large gatehouse that goes all the way down to the floor of the foundation here. The tail race is the water body in this area here. I'll be using that term through the presentation here. And then there's a retaining wall that runs along the foreground of the photo here, which works to retain the hydraulically filled embankment that's off to the right of this photo. And I'll be spending a little time too talking about this valve access shaft. We'll be doing some valve work as part of this project. There's one way in and one way out to get to those valves, and it happens to be right here. So I'll be sharing some photos of that as well. Looking at the spillway. So again, we have a concrete cap monolith structure here that sits atop the rock mass foundation. The district had a log sluiceway here that you see in the middle of the photo. That's since been filled in. As part of this project, there's a service bridge that goes out to that log sluiceway that's no longer needed that we'll be removing as part of this project. But you can see some of the conditions with both the rock and the concrete. The concrete in general at this site, went through a major rehab in the mid 80s, and there are some issues with some of those concrete repairs that were done prior. For example, the concrete has alkali silica reactive nature to it, so that's something we'll be looking to address as part of this project. Looking the other way on the spillway, of course, you can see the embankment dam in the background, the outlet structure here, but more photos of the condition of the spillway. You can see some deterioration of the concrete. Again, that concrete sits atop a rock mass foundation that has a layer or a liner of gunite. You can see that here and here as well. That has some deterioration to it, and you can see some general deterioration of the concrete surfaces as we approach the outlet structure. Looking downstream to upstream now, you can see the control house atop the outlet structure. A lot of the focus of this project is on this outlet structure, which is why we want to familiarize it with you and show you the nearby elements. There's the 3 valve ports. You can see at least 2 of those valve ports are 8-foot diameter here, are an element to the gatehouse. Are basically 3 ways to pass water through this dam. One is over the spillway, one is through the EJ West powerhouse, which is off the screen, and then the third way is through basically this outlet structure and these 3 8-foot diameter valve ports that you can make out in this photo. I have another photo of it later in the presentation. Of course, there's a towel race here. The access to that valve chamber I mentioned before is in this vicinity. And of course, this retaining wall is really critical to support the embankment off to the left of the photo. And I'll make mention too that this is all accessed by some stairs that come along this retaining wall area here that I'll make mention of in a future slide. Being this slide, you can see the condition of some of those stairs, which have settled over time. These were put in as part of the bridge replacement project that the county did around the year 2000. Here you can see the downstream face of the outlet structure, those 3 8-foot diameter valve ports here. There's actually a siphon system incorporated in this outlet structure as well, and the retaining wall off to the left side, and some of the condition of the rock foundation mass off to the right. I mentioned we do a home in on the valve access because that's really critical here. We need to get down to these valves. They're what's called Dow valves. They're 100 years old or very near. So they sit, if you're top side, you'd have to go down through this access hatch. You can see the blue stairs that show up in the middle photo here, and you've got to go down several flights of stairs to get basically to this room where you can see these 3 gauges here that tell us about the position of the valve, open or closed. But you can see 1, 2, 3 valves in a very confined or spatially constrained space with some mechanical and electrical components. There's also it's very wet down there, and some leakage mitigation measures that we want to incorporate in this project to help dry it out. But not a lot of room, and fairly sizable valves. They cannot be throttled. They're either pretty well full open or full closed. So the valve type also comes into play when we consider those remedial measures for the valves. Lastly, to familiarize you with the remainder of the site, there's the bridge. Again, this was replaced around the year 2000 by the county, but you can also see here this retaining wall that holds back the embankment to the rear of the photo has some concrete repair issues that we'd like to address. Characteristic to see a little bit more advanced deterioration around the bridge where we might have de-icing salts, but then also some deterioration around the monolith joints that we'd like to address. So let's talk about what our repair plan is for the project. And of course, we're pretty well through final design at this stage. The drawing you see on the screen, which I realize might be difficult to read, is a work item list that outlines everything we plan to touch or improve as part of the project. What we've done is boiled that down to the 4 primary areas that you see off to the left here, and that is there's a lot of work going into the spillway, a lot of work going into the outlet structure. And I mentioned lastly the retaining walls, and then some also work to the embankment. So I'll go through all those here as part of this presentation, starting with the spillway, which is highlighted. You can see a plan of that spillway going between the EJ West powerhouse here and the outlet structure here. There's removal of the service bridges I had mentioned out to the long log sluiceway. And then we've done a stability analysis of this concrete cap and determined that it needs anchoring in order to be more stable. So these little black dots you see along here are vertical anchors. We'd also propose to resurface the spillway, get rid of some of that ASR prone concrete that was put in the 80s and put in a more robust concrete cap. Also proposing to drill down through this cap and put in a grout curtain, which is basically, you should look at it as if it's a grout wall put within the bedrock foundation, and that is to mitigate seepage, fill any voids or fissures within the rock surface. And then there's also some concrete improvements that we are planning for both the upstream and downstream side of the spillway. The outlet structure looks like this, and this is looking from the downstream view to the upstream side of the dam. You can see the control house here. These are 2 siphon ports. This is the vertical shaft you would go down to get into the valve area, and I will zoom in on all this line work here because it's difficult to see, but basically this is a 10 by 10 shaft where we have to get the old valves out and install the new valves. And you can imagine if you have an 8-foot diameter valve and this is a 10-foot shaft, that things are very spatially constrained to get things to fit up and down that vertical shaft. And valves are very heavy. What we're showing here pictorially that I'll blow up down in the valve chamber, here's the 10 by 10 shaft. We had to put a lot of thought and a consideration about not only how to get the old valves out, but how to get the new ones in place. We're using a gate or knife style valve that will replace the existing dowel valve. We can drop that down via crane here, but we are proposing to incorporate a trolley or a cart system to which we can move that valve body, and each valve will come in 2 pieces. It'll have the main body of the valve here, but also a bonnet that you'll see later that sits on top that allows that blade to come up vertically through the valve assembly. But once that piece is put on the cart and moved from here to here, we then are incorporating a whole overhead crane in order to move it laterally and up and down. And I want to make the point too that we can't just replace all these valves at once. We need these valves potentially to operate during the work, or some of the valves. So we'll be doing them 1 valve, then 2 valve, and then a 3rd valve in a particular sequence. And there's not a lot of space, maybe only a foot or 2 between these valves. So with the spatial constraints we have in the outlet structure, we did develop a 3D model. This is done in Civil 3D or Autodesk product. And the image to the left is a cross section of the outlet structure. We're proposing to line in the 8-foot diameter port down to about 7'6" with what you see in gold. The replacement valve is the red assembly here, and you can see the 2 pieces to that, the lower piece and the upper piece being the bonnet, and then there's a stem that runs up vertically, and then the roof of that outlet structure is really shown to be here, and the overhead crane isn't shown in this particular image. But we're proposing a new staircase to get down into that valve chamber, an access hatch here that's updated, and then a small house structure that you could walk into to better access the valve chamber. And that's shown here as well with the image off to the right. This is looking from upstream to downstream, and you can see the 1, 2, 3 valve bodies, and there's a lot of piping and other things going on in these images, but they show the complexity of the 3D model. These are isotropic views of a similar thing. This has all These are the same image. We just turned off all the existing line work on the image to the right. But again, you can see the gold liner, the 1, 2, 3 valves, the overhead crane that is in this vicinity, the staircase, the trolley system that would transport the valve components laterally, and an access hatch here, a small hoist for servicing and getting equipment up and down, the access hatch, and then an access house here. So that's the makeup of the outlet system. So we've covered spillway.
Just pause one moment, Josh, if you would.
Is that valve just a metal plate?
Yeah, Josh, you want to provide us some more details on the proposed gate?
Yes, so we have a Dow valve currently. That type of valve is basically like a butterfly valve that twists this way within the port opening, and it has a operator that works off the downstream end of that valve blade that's pulled up and down to open and close the valve. It's a bit of an outdated valve system that Dow was the individual 100 years ago that might have sold this particular valve to the district at the time. And those only really operate well fully open or fully closed. One of the advantages to this type of valve body assembly is it basically is a vertical blade that goes all the way up into this red area when the valve is open. It can be opened partially. If we want to open it 50% and have, say, close to 50% flow, we can do that. So these can be throttled. They're called knife gates because that blade moves up and down within that port opening, which is the bottom half of this assembly. So it's two parts. It doesn't fit in one piece. Ideally, it would. These are specialty valves. They would probably come from overseas. I don't know if they'd be made in America even. We've been working with a European valve manufacturer in Zurich, but there may be others that, as we develop this performance spec, that take interest in this replacement valve. But it does operate a little bit differently than what's out there. It is slightly smaller than the existing valve, which is 8-foot diameter. This, I believe, is 7'6", but they perform very similarly. There's not the hydraulic restriction of having that Dow valve blade assembly in the middle of the port, so we get some hydraulic efficiency by completely moving that blade or knife up in the vertical position up here. Does that answer?
It does, thank you.
When, another question, when you pull those Dow valves out and when you put the new ones in, is that staircase going to have to be removed?
We have designed the area such that the new staircase, which is on the downstream side, it'd be reconfigured. Right now, the stairs would be closest to us in this slide. Okay, we're repositioning them in a different orientation on the downstream side of that 10x10 opening, and that gives us about a 5x10 vertical slot to drop that valve body down that is shown right in this zone. So yes, we want a safer, more permanent stair system than what's out there now. The existing one's adequate. It might meet code, but it's not very permanent either. So, and the new stairs would also help facilitate getting workers in and out of the workspace. So I think this would all go in, and then we would start dropping valve components down right next to it. Did I answer your question?
Yes, thank you.
You're welcome. So I think I'm on retaining walls. Retaining walls compared to the spillway and outlet structure are quite a bit more simple. Here we're basically proposing a reface where you see the yellow areas and address the superficial deterioration that we see. We would like to do some seepage mitigation measures along this length here, in particular this zone, similar to the spillway where we drill down through the concrete and grout up the rock mass, we'd like to do that along this retaining wall because we have a foundation interface. We want to make sure that the spillway channel isn't leaking into the earthen dam. So there's some seepage mitigation measures, concrete repair, and then of course the access improvements to address the settling stairs that I showed a photo of before. And lastly, some embankment improvements, not a lot of improvements. We had wavered in our prior studies on what improvements exactly this embankment might need, but through a lot of geotechnical, again, soils engineering, we've come up with a seepage model. This is a cross section of the prism of the dam, and of course looked at the phreatic surfaces, the flows through the dam, and have identified that we think the only improvement that we need for this project would be a relief well system. That would be at the very toe of the dam. Again, the road is here. This is the riprap along the upstream side of the dam. There's a couple of access roads. So we're at the very lower access road where we're proposing to put in 5 relief well systems, and that would help alleviate some of the internal pressures within the dam. One additional thing that we're focusing on that I didn't mention in my prior slides is we're evaluating this particular zone here that you see circled, and this is a plan of course at the site in the Talrace area. You can see some large rocks in the Talrace area here. We believe they were once probably located within what we're calling a scour hole. This is not, I want to clarify, this is not a hole in the dam. This is immediately downstream, but it's in the vicinity of the dam, so we are paying some closer attention to it. It's about 20 feet deep. You can see here with some of the bathymetry. And if I were to take a cross section through the dam along this particular area, you would see this. So similar to the last slide I had, where you can see the dam is made up of different materials, whether it's rock fill, granular shells, core materials. We have a layer of fine sand that sits under this whole dam, and it just so happens that at this scour hole, the fine sand touches the scour hole, and because fine sands are a material that could be transported, we want to make sure that fine sand stays put. So we're doing some modeling. Again, we've got the 3 valves that are in the outlet structure. When those operate, they can be a little bit violent over that scour hole area. You can see some of the turbulence within this photo. And we're using computer modeling to look at the velocities when these 3 valves might be open. Now, I want to make the point that very rarely are all 3 valves open, but when all 3 valves are open, it does show a whole lot of turbulence above that scour hole area. So we're looking and using this modeling as a tool to gauge the improvement over this scour hole area. What that looks like in cross section, the valve flow would be coming from left to right, and you can see some of the turbulence, and this dashed line here represents the fine sand layer down here below a hard pan layer, and we're just looking to use some riprap improvements and doing that in a layered fashion because the fine sand can be needs to be a filtered exit from a dam safety perspective. So paying some attention to this area as we progress to design as well. Would like to move on to discussing schedule. Basically off to the left is the project timeline, off to the right denoting some risks that could potentially derail that schedule. Of course, we're working to mitigate those risks, but what we're working toward here is currently advancing a 60% set to a 100% level of design that we will be handing to the district in OGS in February. Shortly thereafter, we need to meet with FERC. FERC has been involved in the project to date. We, for example, gave them a 30% set and have been communicating with them. They have requested that we meet with them in the springtime to discuss the elements of the project after they've had a chance to review it. And we will then go through a design potential failure mode analysis. And that's just to make sure that anything we do to the dam during the remedial measures isn't posing basically any dam safety risks. Once that coordination with FERC is complete, issue final documents, go into a bid period the summer of 2026, award to a construction contractor, and then we've estimated about a 3-year duration of construction for a completion in the summer of 2029. What are some of the risks to those meeting that design schedule? Well, anything associated with a design delay, an unanticipated design issue. We think we've vetted most of those by now, given we're pretty far along in the design process. FERC review and input, again, we've involved them to date to try to mitigate that risk, but there could be something FERC brings up or a concern that they have that we have to think about and maybe alter the design. When we get into construction, there's some things we have to think about. Of course, we're not hoping for inclement weather, but this is a dam, and if we get a lot of rain, we'll have to deal with that. We have long lead items on this project. Valves could take upwards of 7, 8, 9 months to procure. We, to mitigate that, have identified that as an award submittal. Basically, we're asking the contractor when we award it to get that submittal in and get that ordered up front. There's not only the valves, but the crane. And of course, when it comes time to bidding, we want to make sure we make this an attractive contract for contractors to want to bid on. And of course, we think we're doing that, but that's, you never know or have a good gauge on what type of contractor involvement we might have when it comes time for the bidding process. And we track our schedule in a P6 schedule that you see here on the screen. The top half is more design-related tasks, and I realize it's difficult to read, but want to show you that we're putting a level of detail in the tracking our schedule here. And the bottom half is really that 3-year period of on-site construction. I mentioned construction requirements as an agenda item. What does that mean? Well, we want to do the project with a sensitivity where we're minimizing impacts at the site, whether that be noise, keeping dust down, having a lot of light. We have to comply with SWIP measures and make sure we're not compromising the water quality. We use things like turbidity curtains. So you should see some things out in the water to help protect the water quality and along the site to make sure we don't have erosion issues. We have permit requirements that, of course, we need to adhere to. That might include things like fish relocation, where we're proposing some dewatering within the tail race to work on the valves. We do anticipate some periodic roadway interruptions. For example, those stairs are really close to the road, and we might have to take a lane periodically to do some work up there, but we would coordinate that with the county during construction. And most importantly, this image off to the right is the operational curve for the dam in terms of water level. We are not proposing to change the water level beyond what we would normally do on any given year at the site. So in other words, we won't be draining the reservoir as part of this work. Things should appear in general normal. If you're on the other side of the Great Sacandaga, you probably wouldn't tell much of a difference.
Did you repeat that?
I'll repeat it. We're not proposing as part of the project to change anything outside of normal operating water level procedure.
Thank you.
Okay. I know that was a big question. And of course, the goal here, you can see a photo from 2030. Here they're finishing up the project with some spillway work in the background and operating the valves for the first time. But the project completion is targeted to coincide with the 100-year anniversary of Conklinville Dam.
That was like 1930.
Yeah.
Yeah, this image is from 1930.
I was just wondering who had a hat like that.
The board members, chief engineer in that photo.
You might have been
From
there.
our collection.
They were recruiting reenactors.
Go ahead, Josh.
And I'll close. This is my last slide before we'll open it up to questions here. But we're, of course, tracking the cost of all this with OGS and our other partners, DEC, the district. And again, realize we have itemized cost estimate form off to the left here, but the stuff on the right is probably the things you'd want to see. We have a base construction estimate here that we've developed. We're including what we think are appropriate levels of contingency. We have a target accuracy range that we're targeting as we approach the 100% design estimate. We're understanding the importance of a independent cost review. So we've asked another firm to have an outside that numbers to make sure they think we're on with what cost. This is a web. Means it's at a little of a higher risk of potential for cost fluctuation. We've incorporated field allowances, and those are basically allowances to try to cover costs for things that we think could be variable during the work, whether that's going a little deeper with some concrete repair, having a longer anchor because we didn't have the rock quality we had anticipated. Those sorts of things are covered in what we call cost allowances. So what are some of the risks I mentioned schedule risks, there's also cost risks. Things that we try to track there are, we've seen a lot of fluctuations in material pricing in recent years, trying to capture that in our estimate accuracy that plays in the market volatility, whether it be the valves, the anchors, the concrete, the grouting. We have a lot of those types of materials on this sort of projects. We need to keep an eye on what the market conditions are telling us for those higher cost items. And I mentioned this before, we want to make sure that we present this job to contractors in an attractive manner, and hopefully we get a good competitive contractor bidding pool when it comes time to releasing and awarding the project. So that's my summary of cost.
Josh, I know that in the room with OGS, they're looking to make just a clarifying comment. And when they unmute, you may need to mute because the two of you together seem to be the cause of that feedback before. So just yield the floor to them if you will.
For Josh, just the one question on the target accuracy range. So I'm not used to looking at it that way. But basically, you're saying that this project could go to 58 million. I mean, approximately, if you're going from 0.85 to 1.30.
Yeah, there are rules for different target ranges. For example, if this were a 30% level of design, that's a broader range.
Yeah.
We like to think as we get into more detail that range should shrink.
But right now we should be, because again, this is one of the things when we get into some projects, the costing and stuff. So maybe inside of our thought process, we should be thinking this could be in excess of $55 million.
Yeah, if you take the 43 times 1.3, which is I think what you did, it could get into the 50s.
Tariffs, steel coming from other countries.
So I know OGS is looking to make a clarifying point on that too, Josh. And again, if they unmute, you may need to mute just for a moment.
Muted.
Okay.
This is Brady Sherlock again. So is the feedback okay before I start?
Yes.
Okay. So just to clarify too, and your point is well taken about the target accuracy range. So when we do our OGS projects, we do have, and I'll call it an error bar. So we have, our range for each one of our submissions that is standard for every project, depending on the anticipated construction value, so your point is well taken that, when we estimate, on the high end, you could be seeing a bid value, in that, I'll say 50 and change $1 million range. And that's just how we try to project variation in the bidding environment. The other thing that I wanted to make mention of that is not captured on this sheet, and we can provide a follow-up to this, this is the estimated construction value, the design development contingency, and then our accuracy range. Also, just for everyone's information, there are soft costs associated with this project. That would include our OGS time, the consultant work orders, so the folks at Colliers that are working on the design documents themselves, and then bidding and construction fees. So that tends to average in the 20% range, which is pretty typical in the AE industry. I just thought it was important to make that clarifying point that when you're looking at the project cost in comparison to the construction cost, there are other soft costs associated with the project above and beyond the projections that we are currently anticipating for construction. And if that's something that would be helpful, we could provide an estimate breakdown of what those soft costs typically look like. But I just wanted to make that point that everybody, as you're thinking through, obviously budget is important on the construction side and on the project side as a whole.
So I would just add, if you don't mind muting again just for a moment, I appreciate it. Thank you. I would just add to that and thank our OGS colleagues for that important clarifying comment relative to our close work, and Tim can certainly address any specific questions on this more thoroughly than I can. With our colleagues at Division of Budget, we have come to them with our estimates of our needs, first starting with Conklinville, then expanding to emergent work at Indian Lake, and of course, the Old Forge and Sixth Lake projects. So at every step of the way, when you advance your design, you have a better idea what the cost will be. And of course, the ultimate idea is when you go to construction. But even then, as we've seen, things can change. But as we sit here today, I think, I'll maybe ask Tim to weigh in. I think we have an alignment, can obviously always change. There are other two projects are still underway of available resources for infrastructure work that pertains to regulating district infrastructure and the work that needs to be completed. That can change as we go forward. And as we have done in the past, we may certainly need to go back to our colleagues at Division of Budget. But as we sit here today, that's not the case.
Yeah, no, thank you for that. And the only other thing I'll mention is, our team will continue to keep you informed as the design of the project continues. If there is, any change in what we are seeing in our estimate, we will certainly make you aware of that. And as you mentioned, we, all the way up until construction, we do continue to provide the range, although it does narrow as design, continues and gets more detailed. But our team will keep you informed of any changes that we are seeing along the way. So thank you.
Another question?
I got two questions on that. One question deals with, this is to Josh. As you guys looked at this project and you think the price and you looked at the power plant, I mean, you really didn't look at it, but it's there. Is there anything that we should be thinking about of what we can do to generate more power to help offset the cost over a long period of time? So if this was a brand new dam going in, is there anything that you guys would recommend as experts inside of this area as far as power generation of something that we at least ought to take into consideration, which I'm laughing to myself as I say that because they don't pay us money. Anyway, that we should take into consideration and try to decide, is there something better we should do there to help pay for the cost?
And also, Josh, you can unshare your screen. Thank you.
That's a good question. If
Josh,
we were to look
maybe
at
I'll talk to that too ahead of time, if you don't mind. This is Brady again.
I'm sorry, go ahead.
This is just Brady. If you want to mute for a second, I can talk to this. It's a good question. I think for the current task at hand on our side, we have a scope of work that we are developing and executing. If it is something that the board is interested in evaluating options further for the power creation associated with the dam, I'm sure that's something that the Colliers team would be able to review and assess. And if that is an ask that the board is making of us, we would certainly be happy to, supplement our current task with an additional task. But I just want to make sure that for clarity, that is not part of our current assignment. And we could have further conversation about that. And, Josh, if you have specific feedback on things we could do differently, that's certainly something we can talk about. But, as far as the current project and the current assignment that we've made to, our team and the Colliers team, I think that assessment is not being completed at this time. So
I understand your answer. I understand your answer well, but a lot of times, sometimes you're looking at a project, and then after everything gets done, and you sit back and you look at it, and then somebody comes up and says, hey, if we only thought about doing this at that time. Right? So I'm just, I'm not talking for the board about a bigger project or anything like that. I'm just saying, I'm just looking for an oh shit. This is something we should have thought of and done. That's all I'm asking.
I think Mr. Reagan,
I don't.
to some extent, stand by just a minute, Josh. To some extent, the discussion of the downstream scour in the riverbed is an example of that. That was not, when you go back to Schnabel's scope of work and the initial sort of punch list, which informed our going out to try and procure successfully state funding for this critical infrastructure, that was not on the radar, right? So as the Colliers engineering design team got into it, looked at the project sort of organically, identified that as something that they suggested ought to be incorporated, some level of treatment on that issue as well. So with that caveat, and I certainly hear what our colleagues are saying, I'll also just note that anytime, under the chief engineer's leadership, they've sought to address capital needs. Those needs are attributed to some level of oversight with the non-power generating facilities, DEC, dam safety, and of course, as we have here with a power generating facility, Federal Energy Regulatory Commission. And they sort of develop, here's what we would like to see. That is informed and supplemented by Mr. Fultan and Mr. Mosier and their professional judgment. But that's sort of, we can only go to, if we're seeking external funding, which we have, go to the state with the known knowns. This is what we need to accomplish. But I do want to note, I think specific to your question, that scour hole is an example of something that has been incorporated now in the overall scope as a result of that examination. Does that address in part your question? Yeah. Okay.
No, I'll just add that to your point, you don't want to miss something big. We would have, should have, could have gone back. I don't think there, in my opinion, is anything really obvious that we could incorporate it as part of this project to benefit hydro production. Hydro production is based on having a lot of water that you can pass through a power station, and nothing that what we're doing here is significantly changing that or modifying that. But I will let Rex, who knows more about hydro generation than I, expand if he wants to.
Yeah, sure. And I think you've already touched on these points, but there are basically three ways you can improve power generation, increase the head, which would be raising the headwater level or lowering tailwater level, or some combination thereof. You can't really lower tailwater level because that is the headwater for the next power plant downstream at Stewart's Bridge. And raising headwater would invoke a whole bunch of other stuff, in terms of dam safety. And so that could be potentially very expensive and very problematic. You could increase flow. Right now, there's some sizable head losses within that power channel that goes along the spillway there, leading up to the powerhouse. So that would also involve some major changes to the bedrock that would be, I think, cost prohibitive. And you can increase efficiency of the turbine generator units. I don't know what the status of the machinery in the power plant is, but that's owned by Brookfield, and really is out of the scope of I think what OGS and the district can do.
Thank you. Any questions?
Any other questions?
I thought the dial valves are supposed to be larger, the new ones, so we could let more water out, or not?
No, Josh can elaborate again, but he did mention that the efficiency of the slightly smaller gate, as a result of having the disc in the butterfly format, the disc that sits in the middle of flow is removed, allows that smaller valve the smaller gate to discharge effectively the same amount of water. Yeah.
I think what you are getting is sort of this throttling capacity, which you haven't had before.
That's the advantage of that type of structure, is that we can position the knife gate anywhere in the range of motion from 0 to 100% open, whereas the design of a dowel valve really is never intended to be partially open, because it opens to and subjects the mechanical arm on the downstream side of the butterfly valve to cavitation and erosion by sands and water as the water passes through. And actually, in the full open position, the dowel valve seals that stem in a pipe to protect it from that corrosive or cavitation forces. And having it open partially just kind of defeats the purpose of the design.
And on the two valves, you guys, the maintenance on them and the longevity are equal to or are very similar in their design.
It's I might resort to you, Rex, but this is a very popular and widely used type of valve that we're putting in.
Can you repeat the question? I didn't hear that.
I was hoping this wasn't our first one of doing this one-on-one. This was a technology that's been used a lot. And so it's very comparable to the technology that we currently are using. And hopefully it's less costly and longevity's longer.
Right. Yeah. These are nothing new in terms of valve designs. And with the hydraulic operators and the knife gates, they're, as was said, they're more efficient. They when fully open, they completely out of the flow, so the risk of cavitation or any kind of vibration damage is minimal at best. We're not breaking any kind of new ground technologically.
And the manufacturer, at least in Europe, has been producing valves for, I think it might be fair to say close to a century, or at least the original company.
Do you know the age of Deserk?
No,
And you're muted.
no, I don't know how long they've been in business, but, they're well-known. And
Sounds
one
like
of the few manufacturers of this type of large valve.
Looks very good. Are there any other questions for the team? Well, we got them here. Well, hearing none, I want to thank you. That was a very informative presentation. And we will move on, I guess. That's great.
Thanks, Josh. Thank you.
Thank you, guys.
Thank you.
Thank you. Appreciate everything.
You're welcome.
Thank you, Tom and OGS colleagues.
Bye-bye.
Next, we have staff and committee reports. General Counsel, Mr. Leslie is excused. And Mr. Callahan's going to give us an update, right?
I will, I won't add anything to Mr. Leslie's report that is in the packet, other than to repeat, if we want to discuss anything further about the Brookfield litigation, we can certainly go into executive session. Other than that, I have nothing to add on his behalf.
Okay.
Other than we hope he's having a great trip.
Director of Administrative Services, Mr. Zicki.
Thank you, Mr. Chairman. You will find a summary of my work activity for the reporting period found on page 13 of the board packet. In the interest of time, I will just do a quick update on our annual active permit renewal process. Everything has gone according to schedule. People who paid online last year received a mail notification that the portal was open and an email notification. Everyone else got the cover letter with their paper renewal. As of this morning, 1,838 renewals have been renewed online. We're at 55% already in 1 week, the total of online renewals. So it's going very well. I'd be happy to answer any questions. If not, that concludes my report. Yes.
That's pretty idiot proof. I can do it.
Thank you.
Any questions? Chief Fiscal Officer, Mr. Demetriou.
Please say thank you to that. Thank you, Mr. Chair. You can find the CFO report on page 17 of your packet. Embracing the, in the interest of time, convention here this morning. It just, in addition to the usual reporting of cash on hand, year-to-date revenue expense comparisons with the prior year, just wanted to mention something, a little bit of an update from development I shared in November, which is that the regulating district has filed with the assistance of the tax unit of EFPR Advisory for the first time ever basically a federal tax return and supporting schedules. We had to do that this way in order to apply for the clean energy credits that were included in the Inflation Reduction Act of 2022. We do not have an answer yet from the IRS, but that filing has been made. We've also submitted documents with National Grid that pertain to the electric vehicle charging stations. Taking together these credits, if we're successful, could approach nearly $40,000 that would come back to the district from both of those sources. And so we are hopeful that that will be the outcome, and I'm happy to answer any questions that anyone has about those items or about any other aspect of the regulating district's finances.
Any questions? I guess we have some board expenses.
We do, in fact. I'd like to call your attention to the signed affidavit you can find on page 56 of your packet. If this is necessary and reasonable, expenses incurred by board members relating to their participation in previous board meetings. Article 3, Section 2 of the regulating district's bylaws require the board to approve payments before any reimbursement can be made.
Okay, we have, we need a motion to accept.
I'll make that motion.
Second,
I'll second.
all in favor?
Aye.
Aye.
Oh,
Thank you, Mr. Chairman.
Let me get any other questions? Okay. Next is Chief Engineer, Mr. Fulton.
Thank you, Mr. Chairman, my report begins at page 57. Up in the river area, saw about 30% of historic average precip in the middle of December, and about 28% of historic inflow to the two reservoirs. In the Black River area, we had about 35% of historic average precip, and we had about 27% historic average inflow. Graphs of the reservoir elevations kind of speak for themselves. Closed out the year right on target. Each reservoir, maybe just a slight exception at Old Forge, we were slightly below target elevation. But, reservoirs are currently positioned well for the end of winter and in preparation for spring refilling. And I'd have to take any questions if you have any.
Any questions? Thank you very much. Any other board member questions or comments? If that being the case, did you want to go into executive session? No. Okay.
John answered me.
Okay.
He's gonna
Resolution
get it
for our
done
next,
before I die.
what?
He's gonna get it done before I die. So he answered.
I'm missing one key piece of information to answer that question.
Hey, well, they don't know.
Wellness program in Casa Reagan.
Well, you know how well that is.
I don't.
Well, then we need a resolution for our next board meeting, which is 3/10. There's no meeting in February. 3/10 here at the Second Douglas Field office. Need a motion?
I'll make that motion.
Oh, second.
All in favor?
Aye.
Aye.
Next, well, last is the motion to adjourn. So move. Second? Second. All in favor?
Aye.
Aye.
And for people going to Florida, have a good trip.
Great trip.
Pause for a second. The recording is.
You got me just in time. I ran out of all the little mints.
Yeah.